Hello everybody. In this video, I wanted to introduce you to our Lithofacies modeling tools. So I have a petrophysical analysis here in Danomics. I have came here to the top central drop-down menu and I've selected Lithofacies modeling. Now what you'll see here when you first come in is you'll have tracks for things like your gamma ray, your resistivity, your neutron density, and your sonic tracks. And then you'll notice there are two categorical tracks here, and these are the Lithofacies tracks. And this is using a k-means based Lithofacies. And we have a deterministic Lithofacies track, which uses a set of criteria to assign rock types. So let's explore this briefly on how we can first modify the k-means based methodology. So you'll notice here we have two options. We have a file model and a key-well model. The file model allows you to do a multi-well Lithofacies, and we have other videos out there on that. So I will link to those, or you can find them on our YouTube channel. The key-well model is what I'll focus on here today, and what it does is it looks at the data from your key-well. It then generates the clusters based on the curves you select, and then that model gets applied to the subsequent wells. Now, the options you have available are you have the number of curves that you want to choose. So, for example, gamma ray, neutron density. We can also choose sonic, PE, a linearized resistivity. And as we are doing this, you'll notice that it updates the model clusters. And notice that these clusters, they don't correspond to a specific rock type. These are statistical clusters based on the data. Now, in some cases, we can see that they do often correspond to certain properties. So, for example, here in this Lithofacies, the red facies we have here, facies 2, corresponds to higher resistivity, higher gamma ray intervals, and we can see, once again, higher gamma ray intervals predominantly making up this facies 2, whereas the more pure shell facies are the purple and green here, so facies cluster 0 and 4. So this can be useful because it allows you to zoom out and look at your logs and say, okay, well, anything that's green and purple I know is pretty much a gray shell. Anything that, is like a shaly sand is coming in as this orangish color, and anything that's blue is more of a clean sand. So it gives you a way to visually scan your logs and analyze that. Now, over here to the far right, we have our deterministic Lithofacies. And here, these do correspond to specific rock types. So for example, the gray is a gray shell. The yellowish color here are sands, and the blacks are organic shells. So we can see that corresponds to, for example, the high gamma ray intervals here in the Niobrara. This is done in a much more simplistic way, where we essentially look at things such as the resistivity, the gamma ray patterns, the separation between the neutron and density, and so on, in order to make this analysis. Now, how do these compare? Well, the deterministic Lithofacies, it's based on a general set of rules. You don't have much flexibility in that. Whereas the k-means based Lithofacies, we can not only change the number of curves, we can also change the number of clusters, so we can make that, a smaller number of clusters. If we wanted to, if we felt it was more useful, we could make that a larger number of clusters to give ourselves potentially more resolution in here. So it really depends on what is important to you and what you think makes the most sense for your analysis. One thing to note is when you are using the k-means, it is often useful to use the multi-well file model. And the reason this is important is if your key well doesn't capture all of the rock types adequately, hopefully that multi-well model will allow you to do that. Once again, we have several other videos available on how to perform that. All right, if you would like to use this module but you need a little help, feel free to contact us at support@danomics.com. Thank you.